doing some manipulating variables, and our goal here is to get that u by itself. So a good first step is to remember to follow reverse order of operations. So we know order of operations is PEMDAS: parentheses, exponents, multiplication, division, and then addition, subtraction. So when we are undoing a problem, we want to follow the reverse order. So there's no addition and subtraction here, but we're going to start by undoing our multiplication and division. So if we look, we have 1 over 2L times the square root of ft over mu. So we want to undo that multiplication we have there. And in order to do that, since that 2L is in the bottom, we're going to multiply each side by 2L. That's going to cancel out the 2L on the right-hand side. So we are left with 2LF is equal to the square root of ft over mu. Now that we undid that multiplication, now we can undo our exponents, or undo that square root. And we know to undo the square root, we need to square each side. So that's going to cancel out our square root on our right and leave us with 4L squared F squared on our left-hand side. So we need to distribute that square to each one of those people in our parentheses. If you chose to leave that as 2LF quantity squared, that is a-okay. So then from here, we want to get u by itself. But right now, u is in the denominator. We don't want it in the denominator. So we're going to have to multiply each side by mu to get that out of our denominator. And when we do that, we'll have that mu times 4L squared F squared is equal to Ft. Okay, now it's very easy for us to see that once we multiply that u over to the other side, we need to divide the 4L squared F squared on either side so that we're left with that mu is equal to Ft over 4L squared F squared. Okay. So then for the second one, we're doing some dimensional analysis. So we're going to start with what we're given, our 10.24 meters per second squared. So here, since it's per second squared, we're going to put that second squared in our denominator. So we want to cancel out meters and get to kilometers. We know, and we will be given, that there are 1,000 meters in 1 kilometer. Okay. The reason why we want to write it like that is so that we have 1 meter on top, 1 meter on bottom, cancel out. And right now we're at units of kilometers, which is what we want. Now we can move on to canceling out that second squared. So we know that there's 60 seconds in 1 minute. So right now, if seconds are on the bottom, we're going to put seconds on top so that we have 1 on top, 1 on bottom. They cancel out. The thing that makes this one a little tricky is that since it's second squared, it's really seconds times seconds. So when we multiply by that 60 seconds, we're really only canceling out one of those units. So we need to multiply by 60 seconds over 1 minute. Again, seconds on bottom, seconds on top, cancel. Now we have minutes squared in our denominator. Okay, but we don't want minutes, we want hours. So we know that there are 60 minutes for every 1 hour. Minutes on bottom, minutes on top, those are going to cancel out. But again, since it's minutes squared, we need to do that again to cancel out our other minutes. So multiply by 60 minutes on top, 1 hour on bottom, so that way that other minutes cancel out. So when we plug this in our calculator, we would go 10.24 times 60 times 60 times 60 times 60, multiply by everything on top, and then divide by what's in the denominator. And we should get 132,710.4 kilometers per hour squared. Okay. Awesome. So the key there is remembering if one's on top, you need it on bottom to cancel it out. And then if a unit is squared, you need to do it twice. All right. So then looking at this next one. This is a dimensional analysis word problem, so it's a good job or good idea to underline our conversion factors. So here it says Katie is bad at pronouncing words. Every time she says the word roar, she stretches it out into 8 syllables. That is a conversion factor. 1 roar is equal to 8 syllables. She does this 15 times per song. There's another conversion factor. We see that word per. So we have 15 roars for every 1 song. Okay? When it first came out, the song's played twice an hour. There's another conversion factor. We have 2 songs for every 1 hour. So 1 hour and 2 songs are the same thing. And we want to see how many syllables we have to listen to if we hear it for 180 minutes. That 180 minutes is not equal to anything, so that is not a conversion factor, and that is the number that we want to start with. Remember, we do not want to start with the conversion factor. So we would start with our 180 minutes. So in order to cancel that out, if we look at our conversion factors, we can see hours there. So that's a good hint that we're going to want to convert minutes into hours. So that 180 minutes, we're going to pretend like that's over 1 because there's nothing in our denominator. And we can cancel that out by saying there's 60 minutes for every 1 hour. Okay. Now that minutes are canceled and we're left with hours, if we look at our conversion factors, we know 1 hour is the same thing as 2 songs. So hours on top, hours on bottom cancel out. And once we use a conversion factor, we are done with it. So we've used the fact that 2 songs is equal to 1 hour to cancel out hours. To cancel out songs, we know that 1 song, again, we're putting that on bottom to cancel out the one on top, is equal to 15 roars. Okay, so we've used this conversion factor, so now we're done with it. We're crossing it out. And then last but not least, to cancel out roars, we know 1 roar is equal to 8 syllables. Okay, roars cancel, and we're left with syllables, which is what our question is asking for. Okay, so again, we multiply by everything on top, 180 times 2 times 15 times 8, divide by everything on bottom, divide by 60, and we should get 720 syllables. Okay. All right, so there are our dimensional analysis ones. This next one is looking at trig. Okay, so if we look, our end goal is to find how tall the flagpole is. So we want to find this total height. Okay. If we look, we know from here to here is 192 centimeters because that is the height of our person. So we need to find the height from that 192 up to the flag. We need to solve for that. And our tool to do that is going to be trigonometry. So if we look at this, we know the base has a length of 0.035 kilometers. Okay. So if we know this angle right here, we know the adjacent side, and we're trying to find the opposite. So since we know the adjacent and we're trying to find our opposite, the trig function we're going to want to use there is tangent. Because remember, tangent of our angle is equal to opposite over adjacent. So in this case, we could say tangent of 15 is equal to our opposite, which we don't know, over our adjacent of 0.035 kilometers. Okay. We would need to multiply each side by 0.035 to get that out of the denominator and get x by itself. And when we do that, we would find that x is 0.00937 kilometers. So the height from the person to the flag is 0.00937 kilometers. Okay. So if we want the total height, we're going to want to add these 2 individual heights together. However, we're going to notice that they're in different units. So before we can add them, we need to get them to the same unit. So if our distance from the person to the flag was 0.0093 kilometers, we're going to need to get that into centimeters before we can add that to the height of the person. Okay. So in order to do that, we're going to take 0.00937 kilometers. Okay. And we know that there's 1,000 meters in 1 kilometer. Again, there's nothing in the denominator here, so we're just going to assume it's over 1. So then we can have kilometers on top, kilometers on bottom to cancel out, Right now we're in meters, but we don't want meters, we want centimeters. So we're going to have to use the fact that for every 1 meter, there's 100 centimeters. And again, you'll be given these conversions. Okay, so we multiply that 0.00937 times 1,000 times 100, and we would find that that height there is 937 centimeters. Now that we are in centimeters, we can add the height from the eye to the flag plus the height of the person to get the total length of the flag. And when we do that, we should find that the flag is about 1,129 centimeters tall. Okay, so if we use tangent, since we knew the opposite and adjacent, then we want to add on the height of the person since we're trying to find the total height of the flag. All right, so for this one, if we look here we're trying to find our angle. If we look at that angle, we again know the opposite and the adjacent side. So this is a good hint that we're going to want to use tangent, because tangent is equal to opposite, or 9.8, over adjacent, or 6.2. Here we need to get that angle by itself. So our way of doing that is by doing tan inverse of either side. And then we're going to be left with theta is equal to tangent inverse of 9.8 over 6.2. So on our calculator, we would do second tangent, 9.8 divided by 6.2, and we'd find that our angle, our angle here is 57.68 degrees. Okay. All right, so now we can start looking at our linearizing. Here, we see the number of sales of iPhones measured per year since their release, graphing the data, linearize if necessary, be sure to include units for our axes, and then develop a mathematical model. So here, since the number of sales depends on the time is going to go on our x-axis. So we want to label that with time measured in years. Okay, so make sure you include our variable and unit on your axis. And then on our y-axis, we're going to have the sales, and that's measured in millions iPhones. Okay, so make sure you include what is on each axis and what unit is being used to describe them. Okay, so if we look at our x-axis, we need to go up to 8. So we can scale it however you want as long as we get all 8 points up there. So I'll just go every third. 1, 2, 3. Okay, and then on our y-axis, we need to go up to 230, so I'll go up by 50s. All right, so when we graph this, I'm not going to plot the exact points since we know how to do that, but we should get a graph that looks something like this, okay? And we're going to see that it's direct square. And to linearize direct square, what we're going to need to do is square x values. Oops. So we're going to come up here, and we're going to take all of our x values and square them. So we'd have 0, 4, 16, 36, and 64. Okay. So then what we're going to do is we're going to replot these values using those x squared values. So now our points would be 0, 1.39, 4, 15.79, 16, 58.99. Okay, so we're replotting those values using our x squared numbers. So now instead of just having time on our x-axis, now we have time squared measured in years squared, and we still have the sales measured in millions of iPhones. All right, so still we're again going to need to scale your axes just like we did earlier. But now we have to be able to include our x squared values. So now instead of going up to 8, now we have to go up to 64. So maybe now I'll go up by 10s. Because now we're plotting those x squared values. Okay. And again, I'm not going to plot the exact points since we know how to do that. But when we plot them now we should get a nice straight line, a nice linear relationship. And since here we have that nice straight line, now we can write our mathematical model. So remember, we use the general format of y equals mx plus b when writing our equation. But since we squared our x values, it's not just going to be x anymore, it's going to be x squared. But we like to be more specific when we are writing our equation. So instead of saying y, we're going to say our sales, and that's equal to m, which is our slope. And remember, our slope is a number with units. So to find our slope, we'll pick 2 points and make sure you're using your linearized value since that is the graph with the straight line. So do 0 and then 1.39, and then we'll do 64 and 231.79. Okay. So to find our slope, remember we find the difference in our x values, difference in our y values, and then divide that by the difference in our x values. And again, make sure you use your linearized, your x squared values, not your original x values. And when we do that, we should get a slope of 3.6. Okay. So our slope has a numerical value of 3.6, but we need to include units with that slope. Since we found the slope by doing y over x, we're going to find our units by doing the same thing. We're going to do our y units over our x units. So if we look at our graph, our y units was millions of iPhones. And our x units after we linearized was years squared. So to find our slope, we do y over x. So we're going to find our units by doing y over x as well. So this whole number with units represents our slope. We need to then multiply that by our x variable, which we saw was time squared, plus b, which is our y-intercept. So if we look up to our graph, our data, when time is 0, we sold 1.39 million iPhones. So that 1.39 is going to be our y-intercept. And make sure you include units on that y-intercept as well. 1.39 million iPhones. Okay. The y-intercept, that's going to show how many iPhones were sold in that first year, or how many iPhones were sold in 2007. Okay. According to our model, how many people would buy iPhones in 2017? So to find this, 2017, we started collecting data according to our problem in 2007. So 2017, that's 10 years afterwards. So we're going to plug a value of 10 in for time here. So we do sales is equal to 3.6 times 10 squared, since we squared those time values, plus 1.39. And we would find that we should have sold 361.39 million iPhones. Okay. And then D, when we're looking at independent, dependent variables, our independent variable that's the variable that you are controlling. And in this case, that is going to be time, because we can control how often we're checking our sales of phones. Our dependent is going to be our number of sales, because that depends on time. All right. So then 7, 8, and 9 are our proportion problems. So what might help in these guys is plugging in those changes to see how it affects our other variables. Because in proportions, we're changing one variable and seeing how it affects another. So for 7, if we look at our equation, we are doing 1/2 of v, or we are dividing v by 2. So instead of just having 1/2 mv squared, now we're going to have 1/2 mv over 2 squared. Okay? Because we're dividing v by 2. Okay? And another way to write this, that might make it a little bit easier to see, is if we do 1/2 v. Okay? Because when we do that then, since we're squaring v, if we take half of v, our equation is really going to be multiplied by 1/4, because we also need to square that 1/2. So if we pull that 1/4 out to the front, we can see we're going to have 1/4 of our original value. So that means if we have 1/4 of our original 1/2 mv squared, we're also going to have 1/4 of our kinetic energy. So Ke will also be divided by 4. Okay. If we look at 8, we're saying we're tripling r. So if we plug that multiplier in, we'd have v squared over 3r because we're tripling r. So when we pull that 3 out to the front, it's going to be in the denominator. So we'll really have 1/3 of our original v squared over r. Okay? So if we have 1/3 of v squared over r, that means our a is also going to be 1/3 of its original value. Or a will be divided by 3. Because now we're going to have that 3 in the denominator. Okay. And then last but not least for number 9, here we have multiple things changing. So here we're tripling v, so we'd have 3v squared, and then we're dividing r by 2. All right, so if we are tripling v, but we square our quantity for v, we're really going to have 9 times that original value, because again, we have to distribute that squared to the 3. So we have 9 times that original value, and we're going to have 1/2 our value of r, because r was being divided by 2. So if we pull those multipliers out to the front, we'd have 9 divided by 1/2 of our original v squared over r. Okay? If we're dividing 9 by 1/2, we're dividing by a fraction. That is the same thing as multiplying by the reciprocal, or multiplying by 2 over 1. So we can see that we would end up with 18 times our original value for v squared over r, which means we would have 18 times our original value for a. So in this case, a would also be multiplied by 18. All right, I hope that helps. Please let me know if you have any other questions.